Magnetism Introduction. What happens when you close the door of your refrigerator? It gets drawn and stuck even without a bolt or a lock. Why does it happen so? Simple. This happens due to the presence of a magnet. Even a few pencil boxes or tiffin boxes have this arrangement for fitting the lid. What exactly are magnets? In this chapter, we will read about them in detail. According to Chinese literature, magnetism was known to Chinese as early as 2000 BCE. Chinese discovered that when a piece of magnetite was suspended freely, it always pointed in a particular direction. This directive property of magnetite was very helpful to sailors, who used it to find the direction when they were sailing. Since it helped the sailors in leading the ships in the right direction, magnetite came to be known as the leading stone or lodestone. Magnetism was known to Greeks as early as 800 BCE. Greeks discovered that certain stones attracted iron objects. When these stones were suspended freely, they came to rest pointing in north-south direction. These stones were called lodestones. Thus, lodestone was the first magnet discovered by man. This stone containing iron ore is called magnetite Fe3O4. Later on, artificial magnets were also made from pieces of iron. Magnet. A magnet is an object made of certain materials like iron which can create a magnetic influence or effect. Fact: the magnetic compass was first used around CE 1100. Chinese sailors used it to navigate in cloudy weather. Magnetic and non-magnetic substances. Substances which are attracted by a magnet are called magnetic substances. Examples: iron, steel, cobalt and nickel are the magnetic substances. The substances which are not attracted by a magnet are called non-magnetic substances. Examples: wood, plastic, copper, paper and aluminium are non-magnetic substances. Magnetism. The property by virtue of which a magnet attracts magnetic substances and comes to rest in the north-south direction when suspended freely by means of a thread at its center is called magnetism. Activity. To classify objects as magnetic and non-magnetic. Bring different household objects like a glass, a lock, a pencil, an eraser, a spoon, etc. close to a magnet one by one. You will find that some of these objects are attracted by the magnet, while some objects do not show any attraction or repulsion. Make a note of the objects attracted by the magnet and those which are not. Now, you can classify all the objects as magnetic and non-magnetic. Characteristics of a magnet. Activity. Magnet exerts force. Take a piece of glass and put it over two blocks. Now, spread some iron pins over the glass and put a magnet under the glass. Now, move the magnet in any direction. The pins will move in the direction in which the magnet is moving. This shows that magnet attracts iron and exerts a magnetic force on it. Natural and artificial magnets. Substances like lodestone and magnetite that occur naturally and have the property of attracting magnetic substances are called natural magnets. The magnets which are made by man using artificial methods are called artificial magnets. These are generally made of steel in various shapes and sizes. The magnets can be categorized as bar magnet, horseshoe-shaped magnet, U-shaped magnet, ring magnet, and magnetic needle. Poles of a magnet. When a bar magnet is suspended freely with the help of a string, it always points towards north and south. When this magnet is disturbed slightly, it again comes to rest in north-south direction. The end pointing towards north is called North Pole, and the end pointing towards south is called South Pole of the magnet. The two ends of a magnet where the force of attraction is maximum are called magnetic poles. Note, magnetic poles are actually 2 points very close to the ends of the magnet. Every magnet, irrespective of its shape, has a north pole and a south pole. The strength of a magnet is maximum at poles. As you move towards the center of the magnet, the magnetic power goes on decreasing and becomes negligible at the center. Activity: to locate poles of a magnet. A magnet has two poles, North Pole and South Pole. Spread some iron filings on the tabletop and place a magnet over there. The iron filings start clinging more towards the end of the magnet and very less at the middle of it. This shows that magnetic property is maximum at the ends and minimum at the center of a magnet. So, the regions at the ends of a magnet where attraction is maximum are called the poles. Activity: to show that magnetic poles exist in pairs. Take a bar magnet having North Pole N and South Pole S. Break the magnet from the center. Now, bring another magnet near a broken piece of the magnet in such a way that the north pole of the magnet is near the one end of the broken piece. You will observe that this end of the broken piece behaves like a pole which attracts or repels the magnet. The end of the broken piece is the south pole if it attracts the magnet, and if it repels the magnet, it is the north pole. The other end of the broken magnet will act as the other pole. This shows that poles of a magnet cannot be separated. If a magnet is broken into two pieces, each piece will comprise a north pole and south pole. If you further divide each piece into two parts, then again each part will behave as a complete magnet having both north pole and south pole. So, we can conclude that magnetic poles occur in pairs only. Earth's magnetic field. The Earth behaves as a huge bar magnet as regards its magnetic field on the surface of the Earth and up to a height of about 3 into 10 raised to the power 4 kilometers. However, there appears to be no collection of magnetized solid mass in the interior of the Earth. The magnetic field of the Earth is due to following. 1. The molten charged metallic fluid circulating in the core of the Earth makes it behave like a huge bar magnet. 2. The rotation of the Earth about to its own axis causes Earth's magnetism. 3. It is assumed that the rotation of the Earth about its own axis causes the magnetization of the iron and nickel mass, and the Earth behaves as a bar magnet. Testing a magnet. A magnet can attract a magnetic substance as well as the opposite pole of a magnet. But repulsion occurs only in between two like poles of two different magnets. So, we can say that repulsion is the surer way of testing a magnet. Activity. Repulsion is a sure test for magnetism. Take a metal bar. Bring one pole, north or south, of a magnet near the ends of the metal bar one by one. If both ends of the magnet attract, the metal bar is not a magnet. If one end attracts and the other repels, the metal's bar is a magnet. Thus, repulsion is a sure test for metal bar to be a magnet or not.
Introduction. Which is that one substance without which survival of life forms on earth would become impossible? Yes, water. Plants wilt and die in the absence of water. Animals and human beings suffer dehydration when their water intake is inadequate. Thus, water is the most important necessity of life. In this lesson, we will learn about this precious commodity in detail. Objectives. At the end of this lesson, you'll be able to list some general facts about water, state the properties of water, list the uses of water, explain the concept of water cycle. Water is essential for the survival of all living things, plants, animals, human beings, and other life forms. It covers 70% of our planet in the form of rivers, ponds, oceans, and streams, making Earth appear blue in color when seen from space. In fact, abundance of water has earned Earth the sobriquet, blue planet. Water is tasteless, odorless, and colorless. It dissolves many substances, so it is known as the universal solvent. It exists in nature in three states, that is, solid, liquid, and gas. In solid form, water is known as ice or snow. In gaseous form, water is known as water vapor or steam. But the most common form that water takes is the liquid form. It is in this form that it is known as water. A water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. That is why water is represented by the chemical formula H2O. We use water for various different purposes. On an average, a human being consumes about 60,000 to 80,000 liters of water in his lifetime. Water is used in households for drinking, cooking, bathing, gardening, washing, and cleaning purposes. Irrigation facilities improve agricultural output and help meet the growing demand for food from a growing world population. Irrigation acts as an insurance against the vagaries of nature. Water is also used in industries for cooling purposes. It is used in many industries as a solvent. It is also used to generate electricity. Besides, recreational activities such as swimming, fishing, sailing, and other water sports require water. 97% of the total water present on Earth's surface is salt water, so it is not safe for household, agricultural, and industrial consumption. The remaining 3% is fresh water, 2/3 of which is frozen in glaciers and polar ice caps. That means roughly 1% of all the water on Earth is available for consumption. It is time to check your understanding. Unscramble the words given in brackets to complete the sentences. Have you wondered how, despite consumption of water by living things on Earth for hundreds of years, the balance of water on the planet has been maintained? It is the water cycle which makes it possible. The repeated changing of water in nature from liquid to gaseous form and then back to liquid form is called the water cycle. There are 4 main steps in water cycle. They are evaporation, condensation, precipitation, and collection. Let us try to understand how the water cycle operates. Water in oceans, seas, rivers, etc. gets heated up by the sun and turns into vapor. This process is known as evaporation. Plants absorb water from the soil. They use a part of this water to prepare their food and release the excess water into the air as water vapor. This process is called transpiration. The water vapor rises up in the air, cools and turns into tiny water droplets. These droplets come together to form clouds. This process is called condensation. When the clouds become too heavy, the water droplets in them fall on earth in the form of rain, hail, sleet, or snow. The process is known as precipitation. The water received by earth as rain, hail, or snow goes into the oceans, seas, rivers, and lakes. Summary. Let us summarize what we have learned. Water is essential for life. Water vapor gets added to air by evaporation and transpiration. The water vapor in the air condenses to form tiny droplets of water which appear as clouds. The tiny droplets come together and fall down as rain, snow, or hail. Rain, snow, and hail supply water to rivers, lakes, ponds, wells, and soil. The water cycle is a natural process of circulation of water from the land to the sky and back to the land again.
Science in everyday life. Role of science in everyday life. Man, science. Through ages, man is dependent on natural resources for his primary needs, food, clothing, and shelter, which are necessary for his survival. Early men faced many difficulties, but overcame them and became a civilized man with the help of science only. Science is a quest for truth, a systematized body of knowledge, a way of life. Early men lived in caves. He used stones to hunt animals, ate raw flesh, and led a nomadic life. He observed nature and his surroundings keenly. He produced sparks of fire by striking one stone to another. He burnt dried leaves and twigs to make fire and learned to cook food. Scientists critically observe everything. They search for reason behind everything. They try to find out why and how a thing happens. In this process, they collect the necessary information and conduct many experiments to verify the results. Early men who observed and experimented with his surroundings to obtain results may be considered as our first scientists. Early men, while wandering, observed seedlings, flowers, fruits, and seeds. All these were part of his food. After observing the germinating seeds, he learned how to sow seeds and raise crops. He invented tools to make his work easy. In the same manner, he started observing, discovering, and exploring different things in his surroundings. He developed scientific knowledge and gradually reached a higher civilized modern age. We wear clothes to protect our body from cold, sun, and rain. Early men used leaves and animal hides to cover his body. Later, he used clothes made of yarn. Cotton thread is obtained from cotton plant. Silk thread is from silkworm and wool from sheep. Cotton, silk, and wool are natural fibers. Nowadays, artificial fibers like rayon, nylon, decron, terine, and polyester are synthesized using chemistry, a branch of science. These artificial fibers are being used to meet the clothing needs of our growing population. Early men who lived in caves and tree hollows learned to build huts. Then he learned various methods of constructing houses and huge constructions. Construction of houses helped him to protect himself from enemies and wild animals. Now we are able to build multi-storied building complexes for residential and commercial usage. Wheel and the machines using wheel were invented. With these inventions, the journey of man, which started with bullock cart, passed way to modern means of transport like car, train, ship, aeroplane, etc. Similarly, modern means of communication like radio, telephone, TV, cell phone, internet through computer are bringing the people living in different regions of this earth closer. Role of science in different fields. Science, medicine. Let us see how science has helped the mankind to keep himself healthy. Louis Pasteur, an eminent scientist, proved that presence of microorganisms in air, water, and soil. Harmful microorganisms cause dreadful diseases. To protect ourselves from such diseases, vaccines were invented. Smallpox is eradicated from our country by vaccination. Now, polio is being eradicated through the program called Pulse Polio, in which polio drops are administered to all children. Many children are protected from diphtheria, whooping cough, and tetanus by giving them a vaccine called DPT, triple antigen. Alexander Fleming discovered an antibiotic called penicillin, which helped to control many diseases. Modern science has successfully controlled many diseases, reduced infant mortality, and increased average lifespan of man. Now, science is progressing towards finding suitable drugs to cure cancer, AIDS, and other dreadful diseases. Science, industrial development. Various industries were established to meet the needs of growing population. Example, fertilizer factories, power generating centers, oil refining factories, iron and steel factories, pharmaceuticals, coal industries, automobile manufacturing industries. Science plays an important role in the establishment and management of these industries. Science, food production. We get energy from the food we take. Food is obtained from plants and animals. Higher food production became inevitable to meet the needs of growing population. Through research, new, better varieties of rice, wheat, jowar, etc., which are disease resistant and give high yield were produced. This led to Green Revolution. In the same way, better varieties of animals like cattle producing more milk, sheep and hens giving more meat, hens laying more eggs were developed. Fish and prawns of high quality were also developed. Science, peace and human welfare. Science also led to problems of environmental pollution and overpopulation. It has also created a deadly weapon called nuclear weapon. The use of nuclear weapon produces radioactive dust, which is harmful to human beings, plants and animals. Man is responsible for the environmental pollution caused due to use of pesticides, artificial fertilizers, smoke emitted from vehicles, and industrialization. As a result, man is causing harm to other living forms. Science should be used for the welfare of all living forms and for peace. Science should be useful in the sustenance of human life as well as other beings. Mankind should adopt the principle of live, let live for leading his life.